Obesity in the US is a deadly epidemic. It causes about 300,000 deaths each year. About 100 million adults are obese, so are 12 million children. From 1971 to 2000, obesity rates increased from 14 to 31%. A grossly overweight person has a body mass index, a comparison of weight and height, of over 30 kilograms per meter squared. People with a body mass index greater than 40 are morbidly overweight. The condition increases the risk of type 2 diabetes, hypertension, heart disease and cancer. In 2010, no state had a prevalence of obesity less than 20%. In 12 states, 30% or more of the population was obese. In the United States, the condition costs $150 billion per year in direct medical outlays, which is about 9% of all medical spending. The average adult American consumes about 657,000 calories a year, or 1,800 a day. The body, through a balancing mechanism called homeostasis, knows when it should eat and when to stop eating. Increased calorie intake, lack of physical activity and environmental pollutants that disrupt fat metabolism help explain the condition, but its regulation is in the genes. Hormone signals the need to eat. Obesity genetics. Leptin is a hormone made in fat cells that travels through the blood to the brain into the hypothalamus. The protein, encoded by the OB-LEP gene, acts via its receptor LEPRB as a regulator that balances the intake of energy with its expenditure. When leptin is at a low level, it signals to the body that it's time to eat. When it's at a high level, it does the opposite. People with a mutated leptin gene, or its cell receptors, have a permanent low level of the hormone and insatiable hunger. Since they always have a need to eat, and do, they become morbidly obese. Numerous FDA clinical trials have shown that treatment with the hormone reduces body weight, but only temporarily. It's soon regained. This happens because most humans who are obese are leptin resistant. Leptin resistance happens when the body fails to transport the hormone past the blood-brain barrier into the hypothalamus where it can act on leptin receptors. There is a class of FDA-approved drugs that increase leptin sensitivity by tenfold and causes weight loss, TUDCA, or taurocotioxycholic acid, and 4-PBA, 4-phenylbutyric acid, are used and treat urea cycle disorders and cystic fibrosis. Good brown fat burns the bad white fat stored in tissues. White and brown are the two types of fat, or adipose, tissue. Brown fat, or the good fat, burns white fat as fuel and gives off heat. The good fat is full of blood and iron-rich mitochondria, which gives it a dark color. Both types store fats as triglycerides. The protein PRDM16, proline-rich domain containing protein 16, is a dominant regulator of brown fat. It's able to switch between processor proteins to induce brown fat expression. Modulation of the protein can regulate fat cell expression to favor brown fat. Brown fat is good at converting calories into energy, but the capacity of brown fat to burn calories is inhibited by obesity. Good fat is more closely related to muscle than white fat, and becomes activated when cold. It's critical in keeping infants, who do not shiver, warm. About 2 ounces of brown fat account for nearly 1/5 of a person's energy expenditure. Activating brown fat would cause the loss of about 10 pounds a year without diet or exercise. Inhibitor fights weight gain. The cannabinoid receptor type 1, CB1, is located in the brain. It is activated by cannabinoid neurotransmitters, including anandamide and cannabis. Inhibition of the receptor reduces body weight and blood glucose by increasing calorie burning in brown adipose tissue. There are several CB1 selective inhibitors. Estrogen receptors in brain of women leads to overweight. Estrogen regulates energy expenditure, appetite and body weight in women. Insufficient estrogen receptors in the brain can lead to obesity. 2 hypothalamic centers in the brain keeps female body weight in check by regulating hunger and calorie expenditure. Similar results were not seen in men. Manipulation of PPA-gamma controls weight gain. PPA-gamma is the master controller of fat cell formation. They are cell surface nuclear receptors that receive hormone and chemical signals. PPAR gamma control metabolism of food, carbohydrates, fat and protein, and the genes that regulate energy metabolism. Ligands, agonists or antagonists, are chemical modulators that activate, upregulate or deactivate, downregulate PPARs, affecting fat metabolism and controlling obesity. Controlling ligands: thiazolidinediones, TZDs, agonists that increase the synthesis of proteins involved in fat and glucose metabolism and reduces the level of certain types of lipids, and circulating free fatty acids. TZDs decrease triglycerides, increase high-density lipoprotein cholesterol, HDLC, and low-density lipoprotein cholesterol, LDLC. Resveratrol, an antioxidant present in grapes and red wine, treats obesity. The antioxidant downregulates PPAR gamma, induces calorie restriction, hinders fat storage, reduces cytokines, cell signaling protein molecules secreted by the nervous and immune systems, linked to obesity.